Hello, in this video I'm going to give a demo on keras tensorflow advanced tutorial. So this follows the same steps like the before notebooks that I have explained. First is we set up and import the required libraries and set up the required things. Next, we also in the next cell we compute first, second and third derivative of f of x equal to x and to the power of 4 using a the function, the context, each wrapping the one inside it. Next is here I compute full Jacobian matrix of a vector valued function using Jacobian function which returns all the first order partial derivatives in one cell. Next is of course computing the Hessian matrix of a scalar function using two nested persistent gradient tapes. After that, the next cell implements the straight through estimator using next custom gradient function for quantization aware training. In the next cell, I implement gradient accumulation which simulates a large effective batch size by accumulating gradients across multiple mini batches before applying a single optimizer step. Next cell implements a naive 2D convolution using only TensorFlow tensor operation. After that, I implement a max pooling from scratch by sliding a window over the spatial dimensions and extracting the maximum value in each window using tf.reduceMax. After that, in this cell, implement batch normalization as a class with separate training and interference behaving using tf. In the next cell, I implement layer normalization, which normalizes across the future dimension of each individual sample rather than across the batch. After that, in this cell, implement a dropout from scratch using a Bernoulli mask generated with a random uniform. In the next cell, I build a fully connected dense layer from primitives tf.variable for the weight matrix and bias vector. Next cell implements a 2D convolution layer from the primitives by manually creating kernel and bias as variable objects and calling tf. And for the actual convolution operation. Next, I assemble complete convolutional neural network using the primitive layer defined in the previous cells. After that, in the next cell, I implement a custom dense layer by subclassing keras layer and overriding three key methods. In the next cell, I implement a complete self-attention layer as a keras.layer.layer, creating a query key. After that, in the next cell, implements a spectral normalization as keras.layer wrapper that wraps any existing layer and constrains its large singular value to be at most 1. Next, I implement a ResNet style residual block as keras.layer.layer where the output equals f of x plus x. In the next cell, implements the squeeze and excitation block as keras layer that adds channel-wise attention to future maps. Next, I implement a full transformer encoder block as a keras layer using the pre-norm architecture, which applies layer normalization before both the multi-head attention and feed-forward sublayers. In the next cell, I implement the complete custom training loop using gradient tape explicitly, computing the forward pass inside the tape, calculating loss, retrieving gradients with tape gradient, applying them with the optimizer, and tracking both training and validation matrices. Next, I implement a single TF function compile training step that applies gradient clipping using global norm before the optimizer step. Next cell defines a custom trainable model by overriding the model's train step method, which allows customizing the training logic while using a model fit for the training loop. Next cell loads the sklearn digit dataset, preprocess it, builds a mini ResNet by combining the residual block, squeeze and excitation block. In the next cell, I plot the training and validation loss curves alongside the accuracy curves into two panel figure. In the last cell, final cell, I print a comprehensive advanced cheat sheet covering a gradient tape patterns for the higher order derivatives, custom gradient techniques, gradient accumulation, all three custom layers and modern patterns and custom train step approach. Yeah, that's it with this notebook demo. Thank you.